For this problem, we are given a 12-meter span of non-symmetrical parabolic cable carrying uniform horizontal load of 20 kN per meter. The left support is 6 meters higher than the right support and 9 meters above the lowest half. Determine the maximum tension of the cable. Now, to solve this, we first construct our free body diagram. So using this description, we have the 12-meter span of non-symmetrical parabolic cable. So the overall length of this cable is equal to 12 meters. And it's carrying a horizontal load of 20 kilonewton per meter. And the left support is 6 meters higher than the right support. So if support A here, we call it A, and support B. And A is 6 meters higher than the right support. And the left support is also 9 meters above the lowest half. Okay, now that we have completed our free body diagram, to determine the maximum tension, I believe we first need to calculate the distance from the left support to the lowest half. Let's call this horizontal distance equal to x. And the remaining distance is equal to 12 meters minus x. Now to solve for the value of x, since a parabolic cable takes in the form of a parabola, we can make use of the squared property of the parabola to solve for the value of x. That is the ratio of the horizontal distance squared divided by the height or the vertical distance of the left support, that is 9 meters, should be equal to 12 minus x, the horizontal distance of the right support squared divided by the height, that is equal to 9 minus 6, that is 3 meters. So we have x squared divided by 9, that is equal to 12 minus x squared divided by 2. Keep solving, we get a value of 28 and 39. However, the horizontal distance or the length of the cable should only take values of less than 12 meters. And our result here gives a value that is greater than 12 meters. So we must adjust the boundaries for the x value. Let's set this equal to 0. So we have x is equal to 7.61, and this is a much valid value for us. Okay, now that we have the horizontal distance of x, we're going to solve for the maximum tension. So first, we cut the wires at the lowest side to expose the horizontal force, that is our minimum tension of the cable. And to solve for T minimum, we consider the left side of the cable and taking moments at the support at A. And support at A has both components AX and AY. So let's draw our free body diagram here for the left support and the minimum tension, that's T minimum. There's a horizontal uniformly distributed load of 20 kilonewton per meter. So taking moments at point A equal to 0, we have T minimum, assuming counterclockwise will be positive. This is T minimum times the moment arm distance of 9 meters. And for the uniformly distributed load, this is negative because it induces a clockwise moment. This is 20 times the value of x. That is 7.61 multiplied by the moment arm distance going from the center of the uniformly distributed load. That is 1/2 of x. Equal to 0. And we now solve for the minimum tension. We have T minimum equal to 64.35. kilonewtons. Now that we have our minimum tension, we can now solve for the maximum tension, which usually occurs on the highest support. That is at support A. Now considering support A, we have a horizontal force of AX and a vertical force of AY. And considering the left side of the cable, we have the T minimum tension and the uniformly distributed load of 20 kilonewton per meter. So by taking summation force horizontal, we can get AX that's just equal to the T minimum. So AX is equal to also 64.35 kilonewton. And to solve for AY, we take summation force vertical equal to 0. That is AY equal to 20 kilonewton per meter times the length of X, that is, which was 7.61 meters. So AY is equal to 20 times 7.61, 152.2. Now that we have the value for AY and AX, we're going to solve for the maximum tension. By considering point A and cutting on this section here, we expose the maximum tension, which is just basically equal to the net force acting on A. So that's equal to T max is equal to the square root of AX squared plus AY squared. Since we have the value for AY and AX, we can now directly plug in this value into our equation. We have AX that is 64.35 kilonewton squared plus 162.2 squared, which is equal to 165.24. And that is letter D.